Welcome to Module 4 in this course in Stress Management Skills Training with Biofeedback and Mindfulness. In the course, we're using biofeedback as a tool for developing and training what I'm calling mind-body skills, which include the ability to be receptive to the information your body is giving you, and then the ability to guide your body states towards more favourable physiology. This is based on the idea that there are body states that I'm loosely calling positive physiology that underpin in some sense the states of mind you want to access, emotional positivity and clear thinking and focus, etc. And that being able to access these positive physiological states makes positive mental and emotional states more accessible. And an important part of this favourable physiology is optimal breathing. Breathing is a theme running through the whole course. Each of the 3 biofeedback modalities that the course covers adds a new component to the optimal breathing skill set. In the last module, we worked with EMG or muscle tension biofeedback, which is a good starting point because it's an accessible way into biofeedback training, and also a good foundation for breathing training in the sense that the further development of optimal breathing skills is built on the foundation of abdominal breathing and being able to let the breath all the way out. But muscle tension is not really the most significant biofeedback parameter. There are other more significant aspects of physiology that can be measured. More significant in the sense that getting them right, or optimizing them, makes more difference to how you feel and how well your brain performs. I would say a much more significant aspect of physiology is what we can call breathing chemistry. And I'll say what I mean by that and why it matters in just a minute. In this module, we'll be working with capnometry biofeedback. A capnometer is a device that measures breathing chemistry. As you'll know by now, my business has capnometers for sale and for rent, and it's certainly very useful if you can work with one, but if you don't have access to one, this module is still going to be worth following, at least listening to the presentations, because the material that we're going to be discussing still applies, it's still relevant to you, even if you don't have a capnometer. Okay, let's summarize the objectives for this module. Firstly, you need to understand what breathing chemistry is and why it matters. That's what I'll be doing in the rest of this presentation. Second, you'll learn how to use a capnometer for biofeedback in terms of the software and hardware setup. Then, using capnometry biofeedback will further develop your optimal breathing skills, and then apply them to solving the problems that brought you to the course. Lastly, we'll look at how breathing biofeedback, how capnometry biofeedback can be incorporated into an ongoing mindfulness practice. So what exactly is breathing chemistry? Now, before answering that, I think it's fair to warn you that this discussion will get a little bit technical in places. Hopefully nothing too bad, but I don't want you to be too concerned if you don't take everything in, because at the end I'll sum up the key points that you really need to grasp, even if you don't quite understand all the details. So we know that we breathe in oxygen and breathe out carbon dioxide, and we mainly think of the breathing process as getting air in and out of the body, in and out of the lungs, but that's only just the beginning of the process. We need to absorb the oxygen we breathe in into the bloodstream, and then the bloodstream transports it around the body, and it needs to deliver up the oxygen to the cells that need it, and at the same time collect and remove carbon dioxide, which the cells produce as a kind of exhaust fume. But the thing is, carbon dioxide isn't just a waste product. It actually serves vital functions in the body, and in the blood in particular. In fact, it's carbon dioxide that is key to optimal breathing chemistry. Getting the balance of carbon dioxide right is what breathing regulation is really all about. And by that I mean that your brain's breathing regulation circuitry actually monitors carbon dioxide much more than oxygen as a basis for controlling your breathing. And of course that brain circuit is automatic and non-volitional. We breathe 24 hours a day, and the vast majority of that time we're paying no attention to the breathing. And that's the way it should be. So our goal is going to be to allow breathing to work effectively and not to interfere with it. But more on that later in the module. Why is it so important to get this carbon dioxide balance right? Because when it's not right, when it's dysregulated, the oxygen supply to brain cells is compromised. The blood does not deliver up oxygen to brain cells so effectively. And of course this compromises brain function. Dysregulation of breathing chemistry is in fact surprisingly common, and easily the most common form that it takes is overbreathing or hyperventilation. Because breathing regulation is such a key part of physiology, overbreathing can cause some significant problems. Of course, it's a matter of degree. It's not usually bad enough to cause what you might call medical symptoms, but it often does cause, or at least contributes to, problems like fatigue, brain fog, and mood problems. Most people have heard of hyperventilation in the context of a panic attack, but a panic attack is usually the result of an extreme degree of overbreathing. Much more commonly, there's a mild degree of overbreathing that you may not even be aware of. But the trigger is usually some form of stress. In the last module, we looked at how stress can trigger chest-based breathing, and this is certainly connected to overbreathing. We'll come back to this point later. What are the symptoms of overbreathing? Well, it's useful to divide the symptoms into acute or short-term and then chronic or long-term. Acute symptoms result from transient overbreathing or transient worsening of breathing, and they include a feeling of tightness or restriction in the chest, maybe even pain, shortness of breath or laboured breathing, anxiety or even panic, or just emotional volatility. This happens because the outer part of the brain, the cortex, isn't able to keep in check emotional impulses as it normally would, because it doesn't have the energy due to a lack of oxygen. So anxiety can be both cause and consequence of overbreathing. And for the same reason, you can struggle to focus, or feel foggy or even faint, lightheaded and dizzy, or spaced out or far away as though you're disconnected from the world. You can have nausea, sweating or palpitations. Now, just like chest-based breathing, overbreathing can start off as a short-term reaction to stress, but it can also become habitual. When that happens, the body has to adapt to overbreathing, and it can adapt, but the adaptation is far from ideal, and it can give rise to much more entrenched symptoms that aren't obviously connected to breathing, such as fatigue and low energy and low motivation, insomnia or disturbed sleep, depression, chronic anxiety and other mood problems, and a tendency to headaches and migraines. Poor executive function, which means poor concentration, poor short-term memory or the capacity to hold things in mind, and the ability to keep your purpose and avoid distractions and procrastination. Chronic overbreathing can be connected to gastrointestinal problems such as bloating, indigestion or IBS, and muscle problems, pains, cramping and spasms, and numbness and tingling associated with poor circulation in the hands and feet, and a tendency to have cold hands and feet. There are certain signs that aren't necessarily unpleasant or a problem on their own level, but which, if you notice them a lot, can suggest that you're habitually overbreathing. Sighing is the most common one, also yawning. Irregular breathing and unconsciously holding the breath so that you find you have to take a bigger breath to catch up. Chest breathing and mouth breathing are signs of overbreathing too. And I want to mention one consequence of chronic overbreathing. This is a result of the way that the body is forced to adapt as best it can to the overbreathing. The kidneys have to make an adjustment to what's called electrolytes, and that means the minerals present in body fluids. What happens is that the kidneys start losing magnesium and potassium in urine. These are of course important nutrient minerals, and magnesium especially is important to brain function. Deficiency is associated with anxiety, and since deficiency is common enough anyway, you don't really want to be losing any more magnesium. Let's look at how overbreathing can cause such significant problems. Suppose everything's normal and then some stress comes along. Say you're on your way to an important meeting and you get stuck in a traffic jam or the car breaks down or something. The stress triggers increased breathing. Your breath speeds up and maybe each breath is bigger. In consequence, the carbon dioxide that's dissolved in your blood starts to drop because you've started to breathe it out at a faster rate than your body makes more. Blood concentration of carbon dioxide is actually the key thing. Lowering it causes the blood to become more alkaline or less acid. That's because CO2 is the main determinant of blood acidity. And that's actually quite serious because the body needs to keep the blood pH within strict bounds if it's to function effectively. So even when it drifts a little, there are consequences. And I want to focus on two. First, the blood vessels in the brain especially, but elsewhere in the body to some extent, constrict, and this reduces the blood flow. Second, the blood holds on more tightly to its oxygen and doesn't release it to the cells that need it. These two effects combine to reduce oxygen delivery to brain cells, in extreme cases by as much as 60%, that's 60%. It's really a problem because it's easy to get stuck in a vicious cycle of worsening breathing, where the brain's automatic regulation of breathing is effectively broken. The brain detects the problem as a buildup of CO2 in the brain itself, and it increases the feeling that you need to breathe more. It feels like you're not getting enough oxygen, and that's literally true in terms of the brain, but of course the blood has plenty of oxygen, your lungs are getting plenty in, it's just that the oxygen isn't getting out of the blood and into the brain cells where it's needed. So then you breathe harder, making the problem worse, not better. So this is exactly what happens in a classic panic attack involving hyperventilation. The less oxygen the brain gets, the more the feeling of panic intensifies until something happens to break the chain reaction. Now, if the overbreathing goes on for long enough, and I'm talking maybe as little as just a few hours, then the body starts to adapt, as I mentioned before, to this new lower baseline of carbon dioxide. We don't need to go into the details, but the body makes some adjustments so that the blood pH is returned to the normal range. But the problem is that comes at a cost in the form of the chronic symptoms that we listed earlier, such as fatigue, that you probably wouldn't have guessed have anything to do with breathing. Another consequence is that now the body has much less resilience to further changes, meaning that future stress can tip you into anxiety and even panic much more easily. So the spiral can begin with a simple stressor that triggers an emotionally defensive response, just as we saw in the last module on muscle tension. That is, it causes a tightening up of the various muscles that are involved in breathing, leading to a shift towards chest-based breathing. That's part of the fight or flight response. The diaphragm in particular tightens up and doesn't really let go, meaning that you don't really let the breath out again. Remember, the diaphragm is this dome-shaped sheet muscle at the bottom of the chest. Now, earlier I mentioned that there's a brain circuit devoted to regulating breathing, and in fact regulating carbon dioxide balance. And it basically involves a small region of the brainstem, which is very much the automatic or non-volitional part of the brain, and this region monitors the current situation in terms of the carbon dioxide. It detects how much carbon dioxide is around in the brain. It's the equivalent of the thermostat in your central heating. And on the output side, it links to the diaphragm. And what it does, it turns up or down your ventilation by having the diaphragm move more or move less. But of course, if the diaphragm is all locked up with stress, then the regulatory mechanism is not going to work very well. So in short, if you're stuck in a chest breathing pattern, then you're much more likely to be an overbreather or to tip into overbreathing at times. Conversely, abdominal breathing, where the diaphragm fully releases, letting the breath go right the way out, is going to facilitate breathing chemistry regulation. So breathing chemistry is the primary consideration, and breathing mechanics is secondary, but still important because it has a bearing on the chemistry. So let's just summarize what we've learned so far about breathing physiology or breathing chemistry. Overbreathing is a problem because it significantly reduces oxygen delivery to the brain and so compromises brain performance. It's triggered by emotional influences such as stress or any sense of threat. It's a matter of degree. There's a spectrum of dysregulation from severe to mild. Overbreathing can be context dependent, that is, triggered by circumstances but relatively short-lived, or it can be habitual or chronic. Even when it's chronic, it's likely to be better at some times than others. And when it's mild, you don't necessarily know anything about it. In my experience, it's common for my clients to have no idea that they're overbreathing. And that raises the question of, how do you actually know? No surprises here. I think the best way is to measure it using a device called a capnometer. A capnometer samples the air that you breathe out and it measures the concentration of carbon dioxide. It's not foolproof as a means of assessing overbreathing because it only gives you a snapshot in time. If you dip in and out of overbreathing, it won't necessarily pick that up. But the main point here is that it works as a powerful biofeedback device. That is, it's able to pretty much instantly detect the variations in breathing that are associated with stress levels and the like. This is a screenshot from Biofeedback software showing the trace the capnometer generates. You see that you get a sequence of peaks, one for each breath. Clearly the carbon dioxide peaks in the exhalation, in fact at the end of the exhalation, and then it drops to zero when you're breathing in. Now, the distance between peaks gives you the breathing rate on a breath-by-breath basis. But the really significant parameter is the height of the peak. That height is known to correlate with the concentration of CO2 in blood, which remember is the significant thing physiologically. So that means the higher the peaks, the better. The peak value is called end-tidal carbon dioxide, and the software detects the peak value for every breath and it keeps track of this in another graph. Loosely speaking, when the peaks drop below this dotted line that you can just about see here, which is at 35 on this scale of 0 to 50, that can be considered as a degree of overbreathing. So in the example, there's a brief period of overbreathing here, only for a few breaths. It also corresponds to faster breathing, as you see because the peaks are closer together. Now, I want to just anticipate a common source of confusion here to do with why the readings go lower when you overbreathe and not higher. I've noticed that my clients often think something like this. If I'm overbreathing, that means I'm blowing off too much carbon dioxide. I'm measuring the amount of carbon dioxide in my exhaled breath, so if I'm blowing off too much, then the reading should go high, but it isn't, it's too low. So that's their reasoning, and I'm going to try and explain why it's faulty by comparing carbon dioxide to water in a tank. Again, the key thing physiologically speaking is the concentration of carbon dioxide in the blood, and in my analogy, that's equivalent to the level of the water in the tank, or the height of the water in the tank. So here's our water tank, and it's got a tap at the bottom that allows you to run off water from the tank. By adjusting the tap, you can control how fast the water flows out. And the tank also has an inflow at the top, which is also controllable. If you have the inflow and the outflow matched, then the level of water in the tank stays steady. So the water in the tank is like carbon dioxide in the system, and the new water coming in at the top is like new carbon dioxide being produced by your cells as they burn energy. The outflow at the bottom of the tank is equivalent to carbon dioxide being exhaled by breathing. Now, in this analogy, overbreathing is like opening up the tap at the bottom so that more flows out. The level of the water in the tank starts to go down. That's like the concentration of carbon dioxide in the blood going down. It's true that more water is flowing out, but you've got to remember that the capnometer is really measuring the level of the water in the tank, not really how much water is coming out. Let me repeat that. The height of the peaks in the trace we know correlates to the concentration of carbon dioxide in the blood, which in the metaphor is the height of the water level, which is going low. Now, as the level of the water drops, the pressure drops too, and the rate of the outflow starts to drop too, so that eventually the system finds a new equilibrium. But with the water level in the tank much lower. This is sort of like what happens in habitual overbreathing. It's probably worth just thinking about what happens when you exercise vigorously. Of course you breathe hard, and that's equivalent to the bottom tap being open so that the water rushes out very fast. But this time, because you're exercising, your cells are creating lots more new carbon dioxide, so the outflow is matched by the inflow, and the level in the tank stays high. So even though you're breathing hard, you're not overbreathing in this case, and your blood CO2 level stays good. Actually, if you find yourself in a stressful situation that starts to tip you into a cycle of overbreathing, then a good option is to do something physical if you can, like walk up and down stairs. This will help to get some fresh carbon dioxide into your system. So we've talked a lot about overbreathing and why it's a problem. But of course, it's not all or nothing. It's a matter of a spectrum of dysregulation, ranging from panic attack stations at the extreme through to mild problems where you aren't necessarily even aware that you're not breathing well. Not only that, but the spectrum runs through normal or average breathing and then beyond into what we might call genuinely optimal breathing, or breathing that's associated with states of peak performance in some respect. So optimal breathing is really the opposite of hyperventilation. It's a state of minimal ventilation. In practice, you can't really underbreathe because your body will prevent you unless you have some sort of lung disorder. In other words, you can trust the automatic breathing regulation circuit of the brain never to take you to a dangerous level of underbreathing. But on the other hand, it's easy to go wrong in the other direction, that is, into overbreathing. And optimal breathing really can feel surprisingly subtle. At times it can feel like you're hardly breathing at all. Many years ago, I first experienced this in the context of meditation. I've done quite a few meditation retreats in my time, and I knew from experience, even before I knew anything about breathing physiology, that in states of peak meditative concentration, the breath feels incredibly calm and subtle. And it makes sense because in the state of optimal breathing or minimal ventilation, you're maximizing your brain blood flow and oxygen delivery. In terms of the capnometer signal, optimal breathing is represented by tall peaks, at least up to 40 on this scale of 0 to 50, maybe even 45 or above. So what does optimal breathing chemistry actually feel like? Well, firstly it feels relaxed, but maybe not in the way that you'd expect. It's certainly not the sort of warm, fuzzy feeling that you get after a glass of wine or two. Rather, you feel clear-headed, self-possessed. I'd say you feel like you're driving the bus rather than the bus is driving you. And this clarity helps you feel focused. So it's the opposite of the rather distant, spaced-out feeling of slight overbreathing, which may also feel relaxed in its own way. It's interesting that often people's idea of relaxed is almost the opposite of focused. But actually, it's perfectly possible to be very clear-headed and focused, and yet relaxed, rather like a sportsman who's right in the zone. This state of relaxed focus is really such a useful state for everyone. Although you can feel vividly awake, I've noticed that a lot of people very quickly start to feel sleepy, and then they start yawning. And it's not uncommon for clients to actually nod off in my office, even the stressed out ones who normally struggle to switch off. It's hard to explain why this is. I suspect it happens if you're sleep deprived. It's as if the brain suddenly realizes that what it really needs is sleep. Or it may be that because your carbon dioxide levels naturally rise when you're asleep, there's sort of an association with the sleep state. Actually, this raises a new point, that optimal breathing techniques can be very useful in helping you to get to sleep at night, if you find it difficult to switch off your mind. Let's finish by summarising what's coming up in this module. There are 5 parts, this introduction being the first part. And then in part 2, I'll demonstrate how to set up the capnometer for running biofeedback and how to operate the software. In part 3, we'll look at how to breathe well, how to actually optimize your breathing chemistry so that you can improve the capnometer signal. We'll build on that in part 4. I'll introduce some tools and methods to assist training. In part 5, we'll bring your new breathing skills to bear in tackling the problems that brought you to the course. Here we'll be revisiting the method that we used back in Module 3, namely graded exposure. Lastly, in part 6, we'll look at how optimal breathing can support mindfulness practice, and again we'll be paralleling Module 3. I'll attempt to resolve the apparent divergence between traditional mindfulness teaching, which says, don't try to change the breathing. And we'll look at how capnometry biofeedback can actually enhance mindfulness practice, without going too much against the spirit of mindfulness. So no doubt you're wondering if you're an overbreather or how your breathing measures up. As I've said, I think the best way is to measure it, but that's not the whole story, because you can to some extent judge your long-term tendencies in other ways. Most obviously, you can look at the symptoms of overbreathing. The client intake questionnaire on my website is a good starting point because the report that it generates includes a section on hyperventilation. A more specific and also more standardized questionnaire is the Nijmegen questionnaire. This is specifically about hyperventilation. You can find it online just by typing Nijmegen questionnaire into a search engine. You'll find it easily. One more indicator is a test that you can do at home without any equipment other than a clock or a watch that can measure seconds. It's to measure what's called your control pause. What you do is, after an exhalation, start your stopwatch and time until you feel the first signs of air hunger. So the breath before should be a normal breath, not a big one. And again, you're timing after the out breath. Look out for signs of air hunger in terms of involuntary movements of breathing muscles, such as little twitches in the belly maybe. This measure of control pause actually comes from the Buteyko method of breathing training. They suggest that a control pause of anything less than 40 seconds may point to a degree of overbreathing, and the shorter your control pause, the greater your degree of overbreathing. Personally, I wouldn't like to say how accurate the test is. I think the difficult part is judging the first signs of air hunger. Certainly I'd rather measure overbreathing with a capnometer where possible, but if you don't have access to one, then this test isn't going to cost you anything, so it's probably worthwhile.